So hello everyone, welcome to this another fun test, which is mainly based on mathematics for machine learning and data science. So yeah, we have. I was reading this book. It's a very interesting book, and then I thought, why not I prepare some MCQs and maybe you guys can benefit from it. So when you practice these MCQs, then maybe you can go and read the book for yourself. So the MCQs are based on the first part of the book, which is like the fundamentals of mathematics required for machine learning. And then the second part of the book is like machine learning algorithms. So, and probably in the upcoming sessions, we will talk about that as well. Okay, so just a bit of instructions. So this test is solely aimed for the students to revise these mathematical concepts that are important for working in machine learning and data science. There will be MCQs and some true false as well. And we have assigned time according to the level of difficulty of the questions. And the more correct answer you give and the quicker you give an answer, the more points you will receive. And you will also see your overall score at the end. Yeah, this was the book. So you guys can, I don't know, buy it for yourself or purchase it, I don't know, download it if it's available. I have the hard copy, so I don't know if it's available online or not. Yeah, so in the test, I mean, it's MCQs are from these areas of mathematics like linear algebra, analytic geometry, matrix decomposition, vector calculus, probability distribution, and some questions from optimization theory as well. So these are the areas that are covered in the test. Okay, let's go to question 1. Very well. So let's go to the podium. Great. And I think the Kahoot itself has randomized the options. So the 1, 2, 3, 4. And there is a bit of explanation. So yeah, I think it's very straightforward. Shah, would you like to say something, or
If you, let's say you have a solution, then if you satisfy some of the equations, then you can just play with the equation to see that it wouldn't satisfy the third one.
Yeah, thank you. Let's go to the second question. Very good. That's the podium, and that's how the dimension of the matrix works. Yeah, I think it's pretty straightforward, so we can go to the next. Interesting. Let's go to the podium. Very well. M.A. Huck. Yeah, Shah, would you like to say something?
So a matrix can be seen as a linear operator, and then this homogeneous equation AX equals 0 is just computing its kernel. And we know that kernel is a subspace, so which means you take two elements, you add it, you get again an element in the kernel.
Exactly. Let's go to next question. Very good. Let's go to the podium. Very good. M.A. Huck, Uzma, Ali, Nimra, Ahmad. Yeah, Shah.
It's just the definition, and then you can just play with the four options, and you see that any of these hold.
Yeah, one can be deducted from the other, so kind of. Okay, let's go to the next. Interesting. Okay, that's the podium. There is explanation. Shah?
So it's basically a reformulation of the definition of basis. So maximal and minimal, if you have a minimal generating set, that means you can, first of all, generate any element from those, and you cannot bring that number of elements down. And that's how you define basis for a vector space. And the second one, B, is a maximal linear independent set. It's exactly another way of saying the first one. So, and the third one is the definition you have seen.
Yeah, exactly. Yeah. Okay, let's go next. Shah, go ahead.
Yeah, I think it's quite straightforward.
Yeah. Okay, let's go to the next. Interesting. Yeah, so the correct answer was rank up. Shah, would you like to add? I think it's just the definition.
It's one of the definitions of
Yeah.
rank.
Interesting. Yeah, Shah, would you like to add anything?
Well, so the dimension of the kernel is what usually in the literature are called nullity. And then you can just remind yourself the rank nullity theorem.
Yes. Okay, let's go next. Let's go next. Podium. Almost all got correct. Yeah, it's true. And next question. Oh, very well. Yeah, so it was phi equal to ax, where A is a matrix. It's definitely a linear. Let's go to next. Very good. Still some incorrect answers. And yeah, that's Euclidean norm. Let's go next. Very good. Most of you got it correct. Yeah, so that's definition of symmetric mapping. Interesting. I wonder why we got so many incorrect answers. I hope the option I selected was the correct one. So that's Cauchy-Schwarz inequality. Wow. Shah, would you like to add something? Because many got it wrong.
Can you go back to is it possible?
I think it's not possible, but I believe it was definition of orthonormal basis.
So orthonormal basis would be a vector where you have num1 and they are mutually orthogonal to each other. So the inner product would vanish in pairs.
Yes. And if you take like inner product with itself, then it's 1, right?
There's the norm of it, so it has to be.
Yeah. Okay, let's go next. Good. So go next. Yeah, and that's projection operator. Shah, would you like to add, or it's because
I mean, by definition, a projection is something that once you project and then you further project, you should get whatever you got in the first projection. So square should equals the operator.
great. Sayaka. Yeah, so determinant can be negative, 0, or positive. So the correct answer was none of these. Interesting. Yeah, Shah, would you like to add something?
It's a straightforward formula that the determinant of the inverse is basically 1 over the determinant of that thing.
Yeah, so once you have the determinant of A, you can easily use it to write the determinant of the inverse. Okay, let's go next. Very well. So most of you got it correct. So yeah, all of these were correct. So let's go to the next. Interesting. Okay, let's go next. Shah, would you like to add something?
The eigenvalues are defined by the first equation.
Yes. And if the determinant of that matrix is equal to 0, so it means that it's not a full rank. So the rank should be less than n, right?
Right.
Okay. Interesting. It's the updated Boolean. So yeah, determinant is the product of eigenvalues, and the sum of eigenvalues is the trace of that matrix. So the correct answer was false. Correct was false.